import my own dinner. So when we plug in natural log of 0, it's just automatically undefined, so we have to write it.
When you do what?
When you towards the end, you're going to plug in t, right? And you let t equal 0. When you plug in the like natural log of 0, isn't that just undefined? So, because in the book they don't even write it like in the answer.
Natural log of 0 is undefined, but you're approaching 0. What does natural log do when you approach 0?
Oh, okay. So go to
Negative infinity times.
Times 0. So you have to look for.
You have to work with that. Yeah. Yes.
So the integration of them clean. I was just going to ask for better writing context. That's what I got.
Yeah.
As well. Now we go ahead and rewrite this. You said we're going to do 2 big parentheses.
Not yet. Not yet. Write this in there with your bar and your t and your 1. And then on the next line is where you should do the 2 sets of parentheses and plug in.
And when I'm plugging in for the thing, is it going to be the whole, all of this?
Yes.
Minus
All of that, yes. With the 2 endpoints.
What did you use to integrate the right afterwards?
The second time,
Did you do?
root x over x is 1 over root x. Yeah, I just use the exponents. Like this right here is x to the 1/2, x to the 1. So that turns out to be x to the negative 1/2. Question?
I was asking the same. Yeah.
You're good?
How'd you get negative 4 squared of x?
Well, this right here is right back to this, right? And so I integrate that, and I already know that because I did that a second ago. The antiderivative, that's 2 root x, but then I already had a 2, so it becomes 4. Okay, I'm gonna finish this one off because there's something tricky here in this limit.
Would you factor out that 2 root x?
You could factor out a 2 root x. It might actually serve some purpose, some good purpose there.
When evaluating the line. I know sometimes like factoring something can help us get the.
Yeah, that might let you. I don't know in this one if it's going to help, but let's make sure everyone's on the same page. I'm thinking hopefully now everyone's got the antiderivative okay. And once you have that antiderivative, you plug it back in here and you say, okay, I'm about to evaluate that at 1, I'm going to evaluate that at t, and then I'm going to figure out what I've got. So limit stays here until the very end. 2 sets of parentheses. Plug in 1 first. Happens when we plug in 1. So 2. Natural log 1, 0, minus 4 times 1. So this is just minus 4. The 4 is not under the root. Just minus 4. Now plug in 2 root t, natural log t, minus 4 root t. And then this is the part you got to be real careful about here. If t approaches 0, this right here, both of those together, you could do them separately, but just that right there goes to 0, right? Times natural log of t. What happens natural log of t is we approach 0 from the right-hand side. Negative infinity. Times negative infinity. We do not say divergence here because what we have is something that's getting very small times something that's getting very big negative. This is an indeterminate form. We've talked about this already. Then over here, what's happening? That's just going to minus 0, which doesn't cause a problem, right? So I've got to go figure out right now on the side what happens to root t times natural log t. when I take the limit. So I'll have to use L'Hopital, but I've got to get it written properly first. So this is some scratch work. What is the limit as t approaches 0 from the right of root t times natural log t? Notice I didn't bring the 2 with me. That doesn't matter, right? The constant isn't going to really make a difference. So I just need to know what's happening there. We know it's 0 times infinity. So what's the standard protocol when we have 0 times infinity?
Try to drop one.
Drop one of them down. And I think I'll drop the root t down. Because if I drop the root t down, the derivative of the top will be easy, right? Derivative natural log of t will be easy. Okay, so I'm going to rewrite this as natural log t. Now when we say drop it down, we mean just rewrite it as 1 over it on the bottom. And we'll do a quick check, okay? If I let t go to 0, we know the top is headed towards negative infinity. And if I let t go to 0 here, I have a fixed number over something that's getting smaller. This thing blows up. This whole thing becomes infinite. And so now we have infinity over infinity, which is what we need for L'Hopital. I took that video off that you were.
You saw it, all right?
Yeah, I just looked on my phone and I moved it. It was in that's my college algebra class.
I was like, that's pretty funny.
Yeah.
I honestly thought you were just doing a problem by yourself, and you started talking like, oh, okay.
Yeah. No. I think they were working on a problem, and I was working it out while they were working it. Okay. L'Hopital from here. So I need to let everyone know I'm doing L'Hopital. Do an L or an H. Doesn't matter. Limit t goes to 0 from the right. Derivative of the top 1 over t. Derivative of the bottom. Careful here.
2 root t.
What is it?
1 over 2. We can flip it so it's just 2 root t.
So negative. Is that what it is? Hold on. This is really t to the negative 1/2, right?
Yeah.
And we're taking the derivative, not antiderivative, right? So negative 1/2 comes out. T to the negative 3/2. Yes?
Yes.
So I'm going to write that down. This is negative 1/2 t to the negative 3/2. And this is starting to look kind of messy. So limit, let me get everything in order here. T goes to 0. The top is t to the negative 1. The bottom is negative 1/2 t to the negative 3/2. Do you all agree with that? That's another way I could have written that. Now let me combine those t's together. When you have t to a power over t to a power, you subtract, right? What's negative 1? Take away negative 3/2. Negative 1 take away negative 3/2 is what? 3/2 is what? 1/2. 1/2, isn't it? Okay, so this turns out to be limit t goes to 0 from the right. This negative 1/2 on the bottom, can I write that as negative 2 on top? Yes? And then you said that that turned out to be t to the 1/2, which is square root of t. And now let t go to 0, and you don't have a problem anymore. It's 0.
So the answer would be
So this part is 0, right? This part is 0? So your answer is negative 4. So it converges. And you can tell, I mean, look, we had negative area there, right? So it's probably a good thing that we got a negative answer. So this whole thing now is 0. And then here's our answer right here, negative 4.
Couldn't you have also solved,
Can what?
couldn't you have seen that after you do the derivative, that the ln is 1 over x, and if that goes, if you put in 0, like that whole thing goes to 0.
Where are you talking about?
Like right after, like the first time you do like the L'Hopital,
Uh-huh.
and if you do it right there, that the
If t goes to 0,
that the 1 over t just goes to 0.
that would not go to 0. If t goes to 0, that would become infinite. You have to clean up the power on it first. Okay?
Are you ready for this test? To write it first?
Yeah, I'm ready, I guess. I'm not ready to grade it, but
Are you going to grade it on your spring break?
yes. Yes, I'm going to get it done quick, too, because I don't want to be thinking about it. I've caught up on all my grading, so I have everything of yours. Which what I'll do is I'll just put them in a pile here, and then you can walk out and grab your stuff. All right, let's start a new section. No? You don't want to get ahead?
No.
You sure? If I saturate your brain with more information right now, you don't think that's a good thing?
This is not on the test, right?
What we did today is not on the test. All right, so let's take a look at some of these older exams. Let's see if we can get some idea. So what, fall 15 was last semester? Was that right? Yeah. See what their exam 2 looked like.
Whoa.
6 questions. That was it.
Oh, I just got so sad.
Number 1, U sub. What's U? 2 plus x probably. And then square, yeah. Number 2, trig sub. And notice the limits of integration, 0 to 4, right? That just means it's a definite integral. That means you just need to get a numerical answer. Do we have, is number 2 an improper integral? Is it improper? Like, is it going to have this sort of thing that we have to address?
No.
Is the denominator ever 0? X squared plus 9?
No.
Not happening, right? X squared plus 9 is never going to be 0, so that is not an improper integral. So that's trig sub with the additional topic of you evaluate at the endpoints at the end. 3, long division followed by probably partial fractions, right? But the long division has to come first because the powers on top and bottom are the same. Number 4,
Oh yeah,
force a U sub on that one. Yep. Make U the bottom, du is the top, and it doesn't match, so you make it happen. And then the x squared plus 2x plus 5 on the bottom, that doesn't factor. That's an irreducible quadratic. So what you would do on that one is complete the square. You complete the square on that one. Number 5, improper integral. 0 to infinity, right? Ooh, how are you going to integrate that? How would you integrate that?
How many people failed this test?
U sub? I don't remember. U sub? What's the U sub? The what? Just e to the x.
No, e to the 2x.
Nope, just e to the x. Remember, e to the 2x is really the same as what?
E to the x to the
E to the x
squared.
squared.
I got me so stuck on one of the homeworks, and now
Yeah.
I'm like forever.
You got it. So your u sub is u is e to the x.
Yeah.
So there's u, there's its derivative.
It's just
So this turns into basically 1 over 1 plus u squared du, which is arctan, and you go back to arctan. But remember, for this problem, you would have in front of all of it, limit t goes to infinity, right? 0 to t. So at the very end, you actually have to do a limit that involves arctan, and I told you all about that, to be careful with arctan, right? What's arctan of infinity?
Pi over 2.
Yeah, it's approaching pi over 2, right? Arctan of negative infinity, negative pi over 2. All right. 6. What's 6? Integration by parts. That's how to do the integral, yes, but Anything special on that integral?
You can't let it hit 0.
0, it's undefined at 0. Natural log of 0 is undefined. So that's an improper integral. That's a type 2. And that wouldn't be on the test. But do you see that is what we're doing today? Yes?
Any bonus questions or not?
I think that was it.
No, like for us.
Oh.
Do you open one on there?
Hadn't thought about it.
Make it as easy as the last bonus, but without the cussing.
What do y'all think of that? Not enough questions?
No, that's good.
Is there partial credit?
Yeah, you need to show your work, but yes. Uh-huh. All right, so that was last. Let's look at another one.
Show off to the rest of the professors of how great your class is.
What? Do what?
You could dumb down the test a little and show off to the rest of the professors.
How smart we are.
How great you are?
Sell on it then.
Just all you said.
Take home spring break.
Here's another one. If y'all want to look at another one. Wait a minute. Hold on. Improper. Improper integral. This was last spring.
That was a homework problem, wasn't it?
Probably.
Did you
Probably
change X to the
was.
6 to like X to the
I might have changed it a little bit. Yeah.
okay.
Oh, no. You change x to the 6th to what?
2x squared to the third?
Other way. X cubed squared.
Yeah.
X cubed squared.
Yeah, there you go.
And then x cubed is u. And du is 3x squared, which you almost have on top. So isn't that very much like this problem right here? Very much like this problem. Except instead of u being e to the x, u is actually x cubed here. I remember my students had a problem with that. And then what I did is I said, that was a homework problem. Don't complain. You got to do your homework, right? I gave that problem on another test.
So we can safely assume it's going to be
You can safely assume that every problem you're seeing is going to be on your test. All right. Okay, so this was a different semester, so we haven't done that. Yeah, we haven't done that either. We haven't done that either.
I'm not getting good vibes. Bad vibes over here.
Okay, so we haven't done any of this.
3D. The area between curves?
I don't like that.
Is that the next section?
So many words. Yeah, it's not flipping something.
Okay. So that test was a little bit more. Let me go back to their first test. I think I've shown you their first test. That's too easy to be on your test. What's that? U sub. U is what?
Cosine.
Just cosine x. And then it turns into basically a 1 over square root of 1 plus u squared. And you can actually use a formula off your chart. But you can also do trig sub on that. That looks familiar too. Hey, wasn't that? Oh, that was not the one we did earlier. Looks close to it. There we go. What's that? Trig sub. Because 3/2 really means square root cubed. So that's a trig sub problem. On the bottom is really the square root of x squared plus 4, all of it to the 3rd power. And you use, what's the trig sub you use on that one? X will be 2 tan theta? 2 tan theta. X squared plus a squared.
Are we able to listen to music again on this next exam? Because that calmed me down. Yeah.
I don't know. You know what? I'm going to say no. Here's why. Because I've been really laid back about that stuff, and I don't really have a problem with it personally, but like, I can guarantee you at a university, there's no way you're wearing headphones during a test. There's just no way it's ever happening. So there's no sense in getting you all comfortable like, hey, when I was in this taking Cal 2, like I could have my cup of tea and I could have my whoopee with me and I could have my headphones, you know what I'm saying? You need to get used to being, yeah, you can bring your whoopee. It's okay. If you have a whoopee, you can bring your whoopee. But, I think let's see how it goes without it, all right? Not that I think there's any dishonesty going on or anything like that. It's just, gotta prepare. The biggest thing I see with students is they just don't know how to do a test. They just can't take tests properly. And, part of getting better is to not have any sort of crutch that you need. Go into a room, turn off everything, music off, headphones off, testing environment, give yourself some problems. If you can do those problems without referring to anything, you're probably okay. If you're sitting there going, where's my, you have to reach for something, then you're not there yet, because that's what it's going to be like, right? When you come in here. Oh, yeah, that one. Long division, partial fractions. Hey, this is like a repeat, man. These are like the same problems. That's a match the denominator, right? Let u be the denominator, and then match up the numerator. What here? What about that? Integration by parts. What would u be? I don't know. You'd have to be able to integrate arcsine then. Integral of arcsine? I don't think the integral of arcsine's on. Even if it's there, it's not pretty. The derivative of arcsine turns into like 1 over square root of 1 minus x squared. That's what du would be. That would force you to have to let, this is a good problem. I'm not going to work it out, but let's just look at it. X arcsine x dx. Yeah, I like this problem. Because you're forced in this problem to set up your integration by parts like this. U is arcsine, x in dv is going to be x dx. That's pretty much your only choice. When you differentiate here, 1 over square root 1 minus x squared dx, and when you integrate here, you get x squared half x squared, right? So you do your ultraviolet minus voodoo. Your minus voodoo is going to be minus 1/2 x squared over square root of 1 minus x squared dx.
Wow.
Trig sub. I like that problem. Integration by parts with trig sub in it. Yes, one sine theta, yes. What else? Oh yeah, I think I showed y'all this one. This is the one that like everyone got freaked out when they saw this one. It's a u sub. What's u? The right, just the x cubed part, all of it, the derivative of that is exactly the numerator. That just turns into 1 over the root u. 1 over root u, that's all that turns into. That was the idea, is like people got to the end of the test and they thought that's the hardest problem, like they looked at it, oh, forget that shit. And it was one of the easiest ones on the test. All right, let's see if we can roll back further. Y'all want to stop? We can stop. I'm only doing this for you. Trying to see if there's any variations. Here's an older exam. I don't know. I have no idea. Okay, so there we go. We've got, this is an older one. It's 2013. I can't tell you what was on their exam 1, so, you know. Integration by parts twice. Integration by parts again, the u has to be arc cosine, which means dv has to be dx. Trig sub, long division, followed by partial fractions. Improper integral. Hey, this look familiar? Oh, pardon me. Saved it.
Plus 10 for our test.
Oh, what I always do when I'm not making excuses, but I am making excuses. I always, instead of turning it on silent, I always turn off Wi-Fi. That's what I always do.
Oh, when you have the drop down?
Yeah, I just go in, I always turn off my Wi-Fi when I mean to silence my phone. They look kind of the same. I mean, all right. 6 you couldn't do, 7 you couldn't do, 8, 9. Ooh, that was a good test. Just looking here. Here's a summer exam. Area under a curve. That's basically fundamental theorem of calculus. That's the integral from 1 to infinity, isn't it?
Yeah.
Of this. And that's pretty much, we just did one, right? I walked out of the room, it was natural log x over root x. Pretty much the same thing. We have a discontinuity in here, so that wouldn't be there. That's what we did today. Nope. 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 Okay, this is not applicable. This is a summer class.
It's intensive math, right?
No, summer, it's just faster. Fall 14. All right, let me take this real quick. Yes, sir.
Sorry,
No, it's okay.
my lunch box.
Oh, come on in.
Thank you.
All right, so I think we got 10 minutes. We'll wrap it up. You have a test on Thursday. I'll be here in my office tomorrow, 9 a.m. till 1 p.m., 12:30-ish, because I've got to get up to my other class. If you have any questions, okay? Try and think if there's anything else. Oh, on the test, you can have those 8 formula sheets, right? Is it 8 of them or 6 of them? I can't remember. 6. And then that sheet with the trig integrals, trig substitutions. That's it. That's all you can have. Do what? Teddy bear or a whoopee. But a whoopee, like a whoopee, a blanket, like a cuddle blanket. I didn't either. But I think they call them whoopies. Whatever.